A toy rocket is shot vertically into the air from an 8-foot-tall launching pad with an initial velocity of 104 feet per second. Suppose the height of the rocket in feet t seconds after being launched can be modeled by the function h of t equals negative 16t squared plus v naught t plus h naught, where v naught is the initial velocity of the rocket and h naught is the initial height of the rocket. How long will it take for the rocket to reach its maximum height, and what is the maximum height? So we're given this function, h of t equals negative 16t squared plus v naught t plus h naught. And we're told that v naught represents the initial velocity, and we're told right here we have an initial velocity of 104 feet per second, and we're also told that h naught represents the initial height, and over here we're told that the toy rocket is shot vertically into the air from an 8-foot-tall launching pad. So that represents the initial height. So we're going to be able to substitute these values into the model for this specific situation. So our function is really negative 16t squared plus 104t plus 8. Now the goal of this question is to identify how long it will take to reach its maximum height and what is the maximum height. So what we notice about this particular function is that this function is a quadratic. Because of the leading coefficient being negative, that quadratic will have the graph of a parabola that is oriented down, and the highest y value, which represents the height, will be at the vertex. The maximum will be at the vertex. So the key to finding how long it takes to get to the maximum height and what is the maximum height is to find the vertex. Now we do have a formula for finding the vertex, and we can find h, which it's a little bit unfortunate that the writers of this question chose to use h for height, because we typically use h for the x-coordinate of the vertex. So these two h's represent height, and this h is the x-coordinate of the vertex. Okay, so just wanted to label that so there was no confusion later. So the formula, the vertex formula, is negative b over 2a. A is the coefficient of the squared term, b is the coefficient of the linear term, and c is the coefficient, or c is the constant. So we're going to be able to find that vertex by doing negative 104 over 2 times 8. Excuse me, I made a mistake there. That should be 2 times a, not 2 times c. So c is a negative 16. And 2 times 16 is 32, so we've got a negative 32 in the denominator. 104 divided by 32 would be 3.25. So we found the x-coordinate of the vertex. The x-coordinate in this particular problem, we're not using x as our variable, we're using t as our variable. So this represents the time. So it's going to take 3.25 seconds to reach the maximum height. And then we want to find that maximum height. So we're going to calculate h of 3.25. That's -16 times 3.25 squared plus 104 times 3.25 plus 8. And let's get our calculator to work that out. Okay, so we're going to work this out. In the calculator, we have -16 times 3.25 squared plus 104 times 3.25 plus 8, and that's 177. So that is our maximum height, and our units are feet. It also says here, feet. So we're going to, our toy rocket will reach a maximum height of 177 feet, 3.25 seconds after launch. A 16-inch wire is to be cut. One piece is to be bent into the shape of a square, whereas the other piece will be bent into the shape of a rectangle whose length is twice the width. Find the width of the rectangle that will minimize the total area. So we have a lot going on in this question, so let's start by drawing some pictures. So we know that we have this 16-inch piece of wire. That's the length, the total length of the wire. And that piece of wire is going to be bent into the shape of a square. And what we know about squares is that they have all the same sides, all the same length sides. And then we're also told that we're going to have a rectangle. And for the rectangle, the length is twice the width. So if I allow, say, the width to be x, the length will be 2x. And at this moment, I don't know the width of the square, but let's say that that's y. And so what I know is that I'm going to be taking this piece of wire that is 16 inches, and I want to find the minimum area. So let's represent area of these two figures. The area of a square will be the side squared, and the area of the rectangle will be length times width. So for this example, it will be x times 2x. So it'll be 2x squared. Now, I want to be able to use the same variable in both of these because I want to find the total area. And my question here says find the width of the rectangle, so I specifically want to be using the variable x, which is the width of the rectangle. So I want to be able to change this variable of y in terms of x. And I'm going to be able to do that because of the fact that I am starting with this 16 inches of wire and cutting it, so I'll be able to figure out the value of y in terms of x. So what I'm going to use is the perimeter of this square. The perimeter of this square is going to be 4y, and the perimeter of the rectangle is going to be 2 of the 2x's and 2 of the 1x's. So you can see we have 2 of the 2x's and 2 of the 1x's. So that's 4x plus 2x, which is 6x. So because I'm starting off with this 16-inch wire, the perimeter of the square plus the perimeter of the rectangle have to equal that 16 inches that we started with. So I'm going to be able to solve for y. I have 16 equals 4y plus 6x. I'll subtract 6x. That gives 4y equals negative 6x plus 16. And I'll divide by 4. And that gives me negative 3 over 2x plus 4 equals y. So now what I'm able to do is to rewrite the area function here as a function of x instead of y. So let's do that. So this area function, area equals y squared, can now be written as negative 3 over 2x plus 4 squared. And let's simplify this. This is negative 3 over 2x plus 4 times negative 3 over 2x plus 4. Let's multiply it out. This would be positive 9/4 x squared. And if I multiply it, so that's multiplying the first two, and I'll multiply the outside two. That would give me a negative 12 over 2x. I'll multiply the inside two. It gives me a negative 12 over 2x. And I'll multiply the last two, which would give me 16. I have 9 over 4x squared minus 6x plus 16. That's 9 over 4x squared minus 12x plus 16. And now this represents the area of the square. I want to find the width of the rectangle that will minimize the total area. So I need something that represents the total area. I've got the area of the square plus the area of the rectangle. And I've just worked out the area of the square. That's 9/4 x squared minus 12x plus 16. And the area of the rectangle is 2x squared. Let's add those together. So let's write 2x with a denominator of 4. And that would be 8 over 4 is the same thing as 2. And we can add those together to get 17 over 4x squared minus 12x plus 16. So now we have an area function that represents the total area. And remember, our goal is to minimize want to minimize that total area. So you can see here that our area function is a quadratic. If we look at the value of A, it's 17/4, which is positive. And when we have a positive value of A, the graph of our quadratic is an up-facing parabola, and the min will occur at the vertex. So I can find the minimum value and the value which it occurs at by finding the vertex. We have a formula for the vertex. The x-coordinate of the vertex h is -b/2a. So this is our value of a, and this is our value of b. We'll do -12 over 2 times 17/4. This is 12 over 34/4. That reduces down to 17/2. I can also multiply by the reciprocal. 12 times 2/17, this is 24/17. And I'm going to type this into my calculator to get an approximation. And that's approximately 1.4. I don't have the directions on the screen right now, but they say to round to the nearest tenth if needed, and I've rounded to the nearest tenth. So let's zoom out and recap for a second here. So this value of 1.4 is the width of the rectangle that will minimize the total area. So this is going to be 1.4 inches. So on our square and rectangle, this width would be 1.4. And if I do 2 times 1.4, that's 2.8. And we also found that for our square, y was -3/2 times x plus 4. So this is going to be approximate 1.4 times 3 divided by 2. And that should be a negative. Plus 4 gives me about approximately 1.9. So I just wanted to add up the sides here to see if it got close to the 16 inches that we were supposed to have. So 1.9 times 4 sides. The perimeter of that is approximately 7.6. And for the rectangle, we would have 1.4 times 2 plus 2.8 times 2. So that would be about 8.4. So let's see. 7.6 plus 8.4 does give us 16, the 16 inches. Now those are all approximate because I rounded this answer here. The price P and the quantity X sold of a small flat screen television set obeys the demand equation below. How much should be charged for the television set if there are 90 television sets in stock? What quantity X will maximize the revenue? What is the maximum revenue? and what price should be charged in order to maximize the revenue. So in the first question, in the first part, it says how much should be charged for the television set if there are 90 television sets in stock. And we have this equation at the bottom with the variables P and X. Up here, it's stated that P stands for price and X is the quantity sold. So when we're reading this question, it's saying how much should be charged. This is the price for the television set if there are 90 television sets sold. So this 90 refers to X, and how much should be charged is P. So we can use this equation to help us answer part A. This is called the demand equation. So P is equal to negative 0.15 times 90 plus 330. We'll use our calculator to work that out. We have negative 0.15 times, it should be times 90 plus 330. And the price that we charge for the television set should be $316.50. Now then in part B, it says what quantity will maximize the revenue and what is the maximum revenue. Now in this example, you don't see any variables labeled as revenue, so we're going to have to create this. Now luckily we do have a business formula that we can use, and the business formula is that revenue equals X times P. And the X and the P are the same X and P that were given to us earlier. So we're going to be able to build this revenue function. So we need to build the revenue function, X times P. It's going to be X times negative 0.15X plus 330. And I'll use a distributive property to get negative 0.15X squared plus 330X. So now that we have a revenue function, we can read this problem one more time. What quantity X will maximize the revenue? What is the maximum revenue? So those words about maximize and maximum are our clue that we're going to use the vertex. So just to back it up a little bit here, our revenue function, our revenue is a quadratic. The graph of a quadratic is going to be a parabola. Specifically for this example, A is attached to that squared term, which is negative 0.15. Because that's negative, we know that parabola is going to be down facing, and the maximum will occur at the vertex. Now we do have a formula for the vertex, and that vertex formula is that h is negative b over 2a, and k is f of negative b over 2a. Now in this example, we're not going to use f, we're going to use r for revenue, because we're dealing with the revenue function. So we need to find the vertex of our quadratic here. So h is negative b, that's negative 330, over 2 times a, negative 0.15. Now let's use that calculator. We have negative 330 over 2, let's use parentheses, 2 times negative 0.15. We get 1100. And then K is the revenue at 1,100 units. Negative 0.15 times 1,100 squared plus 330 times 1,100. We'll type that in the calculator as well. So we have 0.15, excuse me, that should be negative 0.15 times 1,100 squared plus 330 times 1,100. And we get 181,500. So we can finally answer part B, and in part B we can say that we will have a maximum revenue of the Y part, 181,500, by selling 1,100 TVs. We've got one more part here in part C. What price should be charged in order to maximize revenue? So remember, P, our price, is with this demand equation. So I'm going to take the 1,100. We need to sell 1,100 television sets to maximize the revenue. So the price that we should charge is negative 0.15 times 1,100 plus 330. That's negative 0.15 times 1,100 plus 330. And we get 165, so we should charge $165 if we want to maximize the revenue. Amy, the owner of Amy's Pottery, can produce china pitchers at a cost of $4 each. She estimates the price function to be P equals 18 minus 3x, where P is the price at which exactly X pitchers will be sold per week. Find the number of pitchers that she would produce and the price that she should charge in order to maximize the profit. Also find the maximum profit. So on this question, we have quite a bit of work to do before we can get to the profit function. So there are some business formulas that we need to be aware of so that we can get to that profit function. So for the profit function, we know that the profit is the revenue minus the cost. And we also have formulas for building the revenue function. The revenue function is X times P, which is the number of units times the price. And the cost is the number of units times the cost per unit. I don't have a variable for that. So let's say that the cost per unit is a lowercase c. This capital C is the cost for all of the units. The lowercase c is the cost per. And we are given the cost per unit, which is right here. So in order to get to that profit function, I first need to find the revenue function, then I need to find the cost function, and then I'll subtract those in order to get the profit function. So let's start with the revenue function. So for revenue, we're going to use X times P, and we're given this right here, the price function, P equals 18 minus 3x. So I can replace that P with 18 minus 3x. And then I'll use the distributive property. That will be 18x minus 3x squared. So that's our revenue function. We can write that as negative 3x squared plus 18x. So then I need the cost function. And the cost function will be that lowercase c times x. We've got 4, it costs $4 to produce, times how many that we produce, so we get 4x. And now that we have both the revenue and the cost function, we can find profit. So profit is revenue minus cost. We have a revenue of negative 3x squared plus 18x minus a cost of 4x. So that's negative 3x squared, and we'll combine those like terms. 18x minus 4x is 14x. So we have our profit function. So if we take a look, we want to find, there are many parts here, we want to find how many pictures we should produce and the price in order to maximize the profit. And we also want to find the maximum profit. So because we're trying to maximize the profit, we're going to take a look at this function. This is the profit function, and we notice that it is a quadratic. And a quadratic has the graph of a parabola. And this parabola has a leading coefficient a of negative 3. And because it's negative, we know that it's a down-facing parabola. That's very helpful for us because we're looking for the maximum. And the maximum is this highest point here, and that max is at the vertex. So if we're able to find the vertex, we're going to be able to find the that maximum profit. So we do have a vertex formula. And the vertex formula is h is equal to negative b over 2a. For our problem, a is negative 3 and b is 14. So we have a negative 14 over 2 times negative 3. And this is negative 14 over negative 6. And that reduces down to 7 over 3. Okay, so this is going to give us a decimal value, but we're going to round to the nearest whole number. So 3 will go into 7 2 1/3 times, so that's going to round to 2. So this is going to be like 2.3 repeating, but we're going to round it to the nearest whole number. And that's going to give us x. So x is the number of pictures sold per week, which is also how many pictures she should produce. We also want to know the price. So the price that she should charge, that will be, this is the lowercase p. So we're going to use this right here, 18 minus 3x. That's 18 minus 3 times 2. 18 minus 6 would give 12. She should charge $12. And we also want to find the maximum profit. So this is the capital P we'll do -3 times 2 squared plus 14 times 2. That's -3 times 4 plus 28. -12 plus 28 would give 16. So we'll have a profit of $16. A maximum profit of $16. On this question, we are given a graph that we see here on the left, and we want to use this graph to find the vertical asymptotes of the function. So what I did here is I pulled up from our notes the definition of the vertical asymptote. The line x equals a is a vertical asymptote of the graph of a function f if f of x increases or decreases without bound as x approaches a. Symbolically, if f of x approaches infinity or f of x approaches negative infinity as x approaches a, then x equals a is a vertical asymptote. So when we're looking on a graph for vertical asymptotes, we're looking for y to increase or decrease without bound. That means we're looking for y to approach infinity or y to approach negative infinity. So we've got our y scale, which is this vertical scale here. And remember, infinity is way up here and negative infinity is way down here. So on our graph, we're looking for the parts of the graph that are either going to infinity or negative infinity. So on our picture, right here, those two pieces of the line, we have the y approaching infinity here and the y approaching infinity on this side as well. And both of them have x approaching where this dashed line is marked. They have x approaching -5 on this side. We use a little plus sign when it's above the number. And x is approaching -5 from below the number. We use that minus sign when we're below. So on this graph, because y is approaching infinity as x is approaching -5, we can say that the graph has a vertical asymptote at x equals -5. So that's the location of our vertical asymptote. Thank you for checking out my videos. Have a great day.